other tasty things, scones maybe, even if we can get somebody to help with minutes. Alan has already kindly volunteered, but we'd like to have a backup person too to help him out. Perfect. Thank you, Martin. No, so we are. It's fine. Settle. You know, there's the shared document thing you can use to.
My experience of doing this is sitting next to the person you're backing.
We do not. All right, we are at time. Okay. Shall we do it?
Do it.
All right. Those people having conversations, we'd like to get started. So welcome everyone to the SCONEPRO BOF. We'll be talking about not baked goods and probably not also this. Not again. So brief reminder of the IETF policies that we all have agreed to adhere to. We're here to do work. That means respecting each other. And the policies that are laid out here, I don't think I need to go through in much detail. Don't think I need to go too much in detail given that it's Thursday and most of you have seen this quite a number of times. But we all agree to adhere to a code of conduct, and there are some disclosure requirements if you have intellectual property. And also, for those people participating in discussions, please remember to say your name clearly at the microphone so that our note takers are able to capture what you say correctly. So, the agenda for today. Marcus will talk us through the current state of traffic policing in networks and some of the experience he has there. Matt will be talking through some of the results that Meta and Ericsson have managed to obtain through some trials. And Brian will remind us why this is not Plus and talk about some of the things that we've learned in the past about network to path and path to network signaling protocols and the sort of constraints we have on that one. But then the bulk of the time here is going to be spent on discussing whether or not we have something that will help us answer the following questions, which is the key thing that we're here for. And I ask that everyone sort of focus their attention on working towards answers to these questions. Is there a problem to be solved here? Do we understand that problem well enough to engineer a solution? This is not research, this is not science fiction. We can turn this into a real thing. And will the work get done? Are people going to implement it? Are people going to deploy it? And are people going to sit down and write drafts and review them and have a functioning working group as a result? So these are the questions we're asking. Please, if you have things that are outside of the scope of these questions, I ask that you limit the time you spend on those things. And so now I'm going to ask Marcus to come and talk through. Do you want to run slides or shall I do it for you? All right.
All right. Hi, everyone. I'm Marcus Ehler from Ericsson, and I will talk a little bit about video shaping and how it's done in networks today and some of the issues with how that's being deployed currently. Next slide, please. So there are a number of networks in the world that do throttle traffic. Especially there are networks that we care about in this BOF are networks that throttle video traffic specifically. And why do they do this? Well, there are multitude of reasons, but in principle, like bandwidth is a shared and limited resource. And when you have networks that are on the RF spectrum, you kind of have even more constraints. So you need various ways of managing your network and your network resources. And at the same time, we know that video is becoming the dominant form of media over the internet. We've had dedicated video platforms for many years, long form videos and YouTube and whatever similar. But also nowadays, social media is more and more driven by video content, usually through these kind of short form videos called reels and stuff like that. So even though there are lots of capacity investments being done in these networks, it's kind of hard to keep up with the demand for data that's continuously increasing. So network operators then tend to take different approaches to managing this. Next slide, please. So when we talk about this kind of content-specific network management and shaping in particular, like where does this happen? So what we've seen is it's fairly common for satellite operators to do this, typically for these geostationary type of networks. We see that cellular operators do this at quite a large scale, but there are large regional differences here. So in certain continents, this is something very common practice. In other continents, this is not common at all. And that depends on various things like legal landscapes and so on. And a small number of wireline operators do things like this, but it's a very small number usually. So next slide, please. So one way to manage networks when we have this situation where kind of consumption of video is continuously increasing, you need to satisfy kind of demands from your customers that they want to have continuous access to video, while at the same time somehow limit the strain on your network resources. So what we used to see in a lot of networks was that we had subscriptions that were limited based on data caps. So you would pay a monthly fee and then maybe you have 5 gigabytes per second, or so 5 gigabytes of data per month, or you pay a bit more and then maybe you have a larger bucket where you can like spend more data. What we see now is more and more operators are providing unlimited data buckets to their customers. So basically you can consume as much data as you want. There's no limitation there, but then what they do is that they do content-specific limitations. So you can perhaps have a cheaper subscription, and then your video bit rates will be limited to a certain quality threshold. And if you pay more, maybe you can have the full range of video qualities. Next slide, please. And why do then operators focus on like shaping adaptive bitrate video in particular? That is because of the nature of these video applications. So ABR video, basically, it has a process where it dynamically selects the video resolution based on estimates and predictions of the network capacity. These predictions are made by the client, usually, and then the video itself is divided into small chunks or segments, and each segment is available in various qualities and resolutions. And then the client, based on its estimate of the network quality or network capacity, selects one quality track that most probably will work well without interruptions to the playback service. And if we go to the next slide, this is something that then can be sort of, this fact of how these services work can be used by network shapers if your goal is to reduce the overall volume that these services consume. So what operators can do then is that they can have some kind of mechanism to detect a video flow. Typically, this would be done through some form of deep packet inspection or heuristic methods. And this is not always easy. You know, protocols have been evolving, and we have a lot of video being carried by QUIC now. So this often actually implies that the network device that detects this traffic needs to do some form of trial decryption of QUIC initial packets in order to be able to extract things like the server name indication field that you would find in QUIC initial packets. And once this is done, and once you have classified a flow, then you can start throttling this flow with a shaper or a policer. We'll go into more details on what that implies later. And then you basically have a policy for these subscribers. You select a bitrate based on this policy. Typically, this is a static policy based on what type of subscription this user has, but there are also possibilities to have sort of dynamic bitrate policies that are based on kind of awareness of the network state. So if you know that your network is highly loaded, you might actually shape your customers slightly more severely than you do when it's not, and so on. And of course, this works because the ABR client will be measuring the network capacity. The time it takes to deliver the content is affected by these throttling mechanisms, and the idea is then that then it will select video of a lower resolution or a lower quality and then consume less data. So if we go to the next slide, we can talk about some of these mechanisms for throttling. So typically we have like two classes of mechanisms to do throttling. We have traffic policers and we have traffic shapers. The common thing between these two is that basically they create a sort of an artificial bottleneck where out of policy packets are not delivered at the rate they're incoming. But then what it does with the packets is different. So if we start by looking at the traffic policer, it will observe the incoming traffic, and when the incoming traffic is exceeding some policy threshold in terms of the bitrate, it will drop those packets just to keep the rate capped at some limit. These policers are often used more for like overall session limitation. Maybe you have a subscriber that have a maximum bitrate overall for the entire session to be, say, 100 megabits per second, and you put this policer in there just to make sure that you don't allow anything more than that. But you can apply this also for some very specific case like this video shaping, where you're trying to get the traffic to match a particular bitrate. That makes it a little bit more difficult because these policers, because they are dropping packets that are exceeding the threshold, you will create a lot of bursts of packet losses. This makes it difficult sometimes for congestion controllers to understand what's going on. Is this congestion loss or is it something else? Because these drops might not correspond to increases in round trip times and so on. So depending on the nature of your congestion control, this might be tricky to understand. And then we have seen examples of this where modern congestion control algorithms build in explicit heuristics to actually detect the presence of policers in the network and kind of try to adapt to them. And to make things even more complicated, oftentimes these policers will allow some kind of momentary bursts of traffic to kind of allow a large burst through and then compensate for that burst by allowing less traffic through for a period of time. And there are multiple ways of implementing this. And this, of course, makes things even more complicated for the senders, because now you have kind of erratic and hard to predict loss patterns. So you might need to build even more advanced heuristics to actually work well with these kind of mechanisms. The other way of doing it is traffic shaping. So what you typically do there is that instead of dropping packets that are exceeding the threshold, you'll start buffering them. So you basically delay packet transmission. So you want to get this sort of smooth idealized rate. That is, of course, this is an idealized picture. It doesn't never look like this in reality, but this is what you want to try to obtain with shaping. And then, of course, the idea is that you can really try to create a specific bit rate and maintain that one. But the problem with this, of course, is that by doing this, you are now adding delay. You're not adding a bunch of loss, but you're adding delay. And then you're increasing the round trip times, and that might or might not impact certain congestion controllers as well. And these mechanisms might also sometimes allow bursts in order to, some traffic peaks and so on. And what happens then is that instead of having this erratic loss patterns, you will now add a bunch of delay variation. And this delay variation is also something that is a bit tricky and complicated for congestion controllers and loss recovery mechanisms and so on to kind of cope with. So none of these mechanisms are like really good, so to say. They both have different shortcomings. And if we go to the next slide, we can talk about a few more issues with this. So in general, these shapers and policers are designed to kind of enforce a network policy. Originally, these mechanisms are not designed to kind of create a good user experience. It has more had to do with protecting your network or fixing a network policy and so on. Of course, you can tune your shapers to be more friendly to user experience, especially when you use them for these purposes, like shaping video in particular. But this is difficult because as a network operator and a kind of tuner of these functions, it's actually quite difficult to understand what the quality of experience impact of your tuning decisions really are. And you might have teams that work with this and figure out, okay, yeah, this video service responds in this way to my shaper configuration, but that might change very shortly after because these services are very dynamic. And there are also multiple providers of these services, and they might use very different technologies, right? So it's difficult, and yeah, it's hard to know what to do. And another thing is that for this to work properly, you need to do proper traffic detection, right? You need to observe the flows passing through your network, and you need to know which of these flows are video flows and which are not, which are candidates for shaping. And this is becoming more and more difficult as these protocols are increasingly encrypted, right? And like I said in a few slides ago, that for instance, if you want to extract SNIs from quick packets, you actually need to decrypt them. You need to know which version of, or you need to guess which version of quick it is. You need to find the initial salts, do that decryption, parse the quick packet itself to find the SNI. So it's quite a lot of work. And of course, you can also resort to more heuristic alternatives, basically looking at traffic patterns and combinations of things, but that is a bit fragile and could be error prone. And yeah, so it's difficult. Of course, there are other ways of doing this. There are communication service providers and network operators that work with specific vendors or specific providers of video services, and they build like proprietary solutions for handling this, maybe to allow self-regulation of the video and so on. But then they need to handle this very specifically with proprietary agreements and so on. So we have a situation where all of these different communication service providers work with different vendors with slightly different implementations of shaping or policing. Some of them work specifically directly with certain video service providers, and it's just a big, quite difficult landscape to work with. And we hope we can do better. So if we go to the next slide. Yeah, so is this current situation as good as it gets? This is not a scone. This is Swedish knäckebröd. It's a bit dry and a bit dull. I mean, it kind of works. It gets you full, but it can be yummier stuff out there. So yeah.
Okay, thanks, Marcus. Matt, do you want to give us the next one?
You guys can do the slides. I'll say.
Yeah. Oh, getting better.
Hi, everyone. I'm Matt from Meta, and I'm going to talk about a proof of concept lab trial that we did with Ericsson using Mask as a sort of feasibility study for something like SCONEPRO. Next slide. So Marcus did a really great job going over ABR video, but this is just another diagram to reinforce the point of how modern ABR schemes like HLS and Dash work. So very briefly, when a user uploads a video, that the content server will break that video down into multiple segments and encode each of those segments at different bit rates, and those correspond to different qualities. And then the thing that makes ABR video adaptive is that the client is able to, on a per segment basis, change the bit rate that it's requesting and playing back. And like Marcus said, this is done generally mostly based on client-side heuristics. So literally trying to measure the download speed and doing other sort of tricks to try to make a guess, basically, what bit rate can it sustain at any given point. And this is why when you play back video, you'll see the quality ping-ponging and doing different things. And so, and like Marcus said, shaping is a way that we can target this kind of traffic and get different outcomes on the application behavior. But it's using a network level adaptation in the network to get a second order result from the application. Next slide. So the proof of concept that we're going over here is essentially to, instead of having a network level adaptation, we just have a signal from the network that gives the application the ability to apply a application level adaptation, but also a transport level adaptation, which we'll get to in a second. But in this case, instead of having all of these qualities available up to 20 megabits per second, the client in this case knows that the max quality it should get is 2 megabits per second, and so it self-adapts and will cap its own quality there and never exceed it. Next slide. So now let's actually talk about the proof of concept we did. So mask and connect UDP, it's not actually what the RFC is called. It's called proxying UDP datagrams in HTTP, but everyone calls it connect UDP. Basically, this is a way that we could easily experiment with this because it's an existing standard. Ericsson had existing software to do this. We had existing software to do this. And it has a lot of similar properties to what we would like from something like SCONEPRO. And if you read our requirements documents, it ticks a lot of the boxes. And we also think that from a broad level, if we can implement and deploy something like this in a trial, it's a good feasibility metric for whether it's possible for something like this to actually be done with real traffic. Next slide. So diving into the details a little bit, this is kind of an overview of what this thing that we built is doing. So on the left, we have the literal Facebook app. So this is literally the Facebook app. And we also have a mask server that's in a real packet core. And the Facebook app will connect to that mask proxy server and then start sending its end-to-end quick connection to the Facebook video CDN server. And then this goes, the mask proxy server does what it does, and it proxies them and sends it to the other side. And I think for people that aren't familiar with this, a couple important things to note is that this proxy server is not able to see the traffic. So these orange boxes, that's a cryptographic context between the Facebook app and the Facebook video CDN. The proxy server is not privy to what is in those packets. So it is literally being a proxy. It's similar to like how a VPN might work. And so on the left, we just have this light layer of outer encapsulation from the mask connect UDP, and then that little sliver of blue is what we are calling the media rate signal, and that contains the information from the network that says, hey, this is the media rate information that I want you to base your self-adaptation on. So the details of this are in a draft from Marcus that you can see if you are curious, but that's the overall idea. Next slide. So to make it a little bit more concrete, just so the flow is more obvious, just with pictures, the way that this proof of concept is working is that the Facebook app will connect to the mask proxy server. It will start exchanging its, the packets for the mask connection. Next slide. And then once that is established, it's able to make its normal video connection all the way to the CDN, and then the normal video playback flow happens. And as part of that, as we've noted, it gets a list of available qualities for this video. Next slide. And then what happens is as part of the SCONE thing, we get this media rate capsule that the Facebook app is able to read. And then first it applies a application layer adaptation, which is to say that it limits the qualities available. So it sees, the media rate is 2.5 megabits per second. I will cap myself at 2 megabits per second. Next slide. And additionally, this is not something that we necessarily think is strictly required all the time, but we thought it'd be interesting to experiment with, is that it also instructs the video CDN to apply a transport layer adaptation. So the video CDN server will also cap its max send rate to 2.5 megabits per second. So in this case, we have both a application layer adaptation and a transport layer adaptation. Do we want to give Lars, I assume this is a clarifying question?
Lars Eggert, Mozilla. So clarifying question. I probably would know this if I had read the draft, but I didn't, so I'm going to ask. Is the stuff in blue encrypted or is it clear text?
Yes. So the from the Facebook app to the mask proxy server, what's being sent there is a capsule, an HTTP capsule. So the Facebook app and the mask proxy server have an independent cryptographic context from the end-to-end quick connection. And so no one is able to read that except for those two parties. So yeah, the client in this case is the only one that has all of the cryptographic contexts involved. Tommy?
These had better be questions for clarification.
Absolutely. So the clarification here, when you're communicating like a media rate in the capsule, is that one value that's bidirectional? Is it able to communicate different things? Like, just want to understand, like when we're reflecting up to the Facebook server, is it potentially different than what you're limiting yourself to on the client?
That's a good question. For the purposes of this proof of concept, what's in that signal is somewhat simple, and we imagine that if we did this for real, that information could be more complicated and more nuanced based on like what the network requires at any given time. In this case, they're essentially the same, and well, the send rate is a little bit higher than the bit rate of the media. Because of like how the media is often encoded, we often request a much slower bit rate than what the transport can actually provide. Jana
Iyengar, Fastly. Sorry, I'm going to ask you to repeat this because I'm a little bit confused because your picture is a little bit confusing. When you say Facebook app, you mean the client, correct?
Yes.
Okay. The media rate of 2.5 megabits per second is going from the app to the mask proxy. What is the send rate, max send rate there of 2.5 megabits per second? Is that actually something going on the wire, or is that
okay. So the way this literally works is the mask proxy server sends that capsule that says 2.5 megabits per second. The Facebook app sees that and is able to cap its video bit rate it's going to request. And then it also, the Facebook app says, hey, Facebook video CNN server, please set your max pacing to 2.5 megabits per second.
And that's the text up there on top of the blue.
Yes, that's that blue is my attempt to say like, look, I've done something to this arrow.
Got it.
And I've capped it.
I think you should use unidirectional arrows here. That's
okay, we're getting live review of the slides from Jana. Thank you, Jana. Yes.
Just trying to understand. Thank you.
Yes, so that is what's happening. So we have two, the key point is that there's two adaptations. We have an application level adaptation and a transport level adaptation. Okay, okay, we've got another one.
Sorry, Jonathan Hoyland, Cloudflare. So I thought I understood, but now I think I don't.
I blame Jana.
How does the client know this media rate? Is it trying to like self-discover it from the network? Or
No, it's an explicit. So the mask server in this case is literally sending an HTTP capsule. It knows it.
So we're assuming that the client has like a fiber connection to the proxy server?
No. So the client made a mask connection to that server voluntarily.
That mask connection is going over some medium, and that's
in this case, it's going over an RF medium. This is connecting to a literal packet core.
So we're assuming that the client knows the limit of the RF medium.
No. Is that limit is emergent from the network, and the mask proxy server is sending it.
Maybe I can step in.
Yeah.
I want to make it very clear. People keep seeming to miss where this number of 2.5 is coming from. Yeah. Can you 100% elicit who creates the 2.5?
Yes.
And where do they send it?
The 2.5 is coming from a device in the network in the packet core. This is literally in a packet core, and it is sending it to the client.
Okay. The arrow is going both ways is confusing.
The arrow is going both ways, and that is confusing. But yes, so the blue box is coming from the little thingy, the little squiggly thingy in the middle that says Packet Core Proxy Mask Server, and then it is heading towards the Facebook app. Okay, so hopefully that is now clear.
Carry on.
Yes. Okay, next slide. Okay, and now I have an even more complicated picture. So I don't think this is going to clarify anything, but this is the actual setup. So this is mostly to reiterate the point that we had a literal packet core with literal RF antennas and stuff. Like it's literal, it's a thing. So, and just to make it a little bit clear, the red line here is the normal path. And the normal path here goes through a shaper. So there is a shaper that is configured as a operator would often configure it. And so that is normal. And so we were able to run tests where we say, for this fixed video playback, video playlist, go through a network shaper and then repeat it and go through our self-adaptation instead, which bypasses the shaper. So in the red line, we have video playback going through a shaper, and in the blue line, we have no shaper, just self-adaptation. And then there's lots of other boxes, and that's because packet cores are complicated, blame 3GPP, and then yes, this also egresses to the real internet and hits the real Meta CDN. So this is the lab setup. Next slide. Okay, so let's get to the results. Before we get to the results, I think there's a couple things I want to say, which is this repeated testing uses a fixed playlist. So we have the ability to basically, for the real app, have a fixed video playlist that we repeatedly test just to eliminate any sort of problems from having different videos. And we're comparing shaping at a fixed bitrate, and this shaping configuration is indeed a shaper. So like Marcus said, this is not a policer. This is something that's building a queue. And we think it's a realistic representation of what operators actually do. And the self-adaptation has two adaptations. One is the application one, which is capping quality, and the other one is the max send rate, which we've talked about a little bit. And the big TLDR, if you don't get anything from these results, is that we are able to achieve a better video experience with similar network tonnage or data usage. So for almost identical amounts of data usage, the self-adaptation has a better video experience. Next slide. Okay, and now we have to talk about video quality, because I made a big bold claim about why that it's a better user experience. So the numbers that you're going to see, the first one is one that's called the Video Multi-Method Assessment Function, or VMAF. And this is basically just a number that represents relative video quality. And then the second we're going to get into is stalls. This is much simpler. This is how much time there was a spinner on the screen, basically. So a couple things for people that aren't familiar with video is that one thing that's important to note is that higher peak quality is less important than consistency of quality when you're playing back a video. And so this kind of makes sense, which is like, you're not really pixel peeping when you're watching video on your phone. So like having a moment of like, oh my gosh, this is, a moment of 4K is a lot less important than like, keeping that video quality consistent and not dipping down into like potato quality. And that leads to the next point, which is that lower qualities are very damaging to user experience. So it's very frustrating when you're watching a video and then suddenly it dips to like 240p and you can't really tell what's going on. And so that lower quality is going to make people much more frustrated than getting some peak quality. And then the last point is that I can't stress this enough, that outlier experience is extremely important, both in aggregate across populations, but also within a single user session. If 1% of the time you're getting a very bad quality experience, that's still really bad. 2%, that's still really bad. Like, we want to avoid that. And users really do not like this kind of thing, because users are us, we are people. So if you think about it, like if you ever get that kind of experience, you're much less likely to have a good time. Next slide. Okay, so now we're finally going to get to the data. So this first one, looks a little bit scary if you've never seen a CDF before, but a CDF is basically a way to visualize a distribution via percentiles. And so this is a CDF of VMAF, which, as we said before, is about video quality. And so the way to read this is that on the y-axis we have percentiles, and on the x-axis we have the actual video quality values. And so the red line is represents the network shaper, and then the blue line represents the self-adaptation. So a couple quick key points on this one is that I've drawn a vertical arrow at VMAF equals 80%, and this is accepted generally as the threshold of annoyance. So things below this, you're getting an annoying video quality experience. And so the key thing to take away from this is that the percentiles of annoyance are very different. So for the shaper, you have about 36% of the distribution falls below that annoyance threshold, whereas with the self-adaptation, we have only about 7% is below that threshold. So you have a lot more. The way to think about this is there's a lot more people that are getting an annoying experience. And so there's more nuance on the right side of that distribution, which we can talk about if people are really curious. But for now, let's move on to the next slide. Okay, so getting away from the CDF, this is just a classical histogram that's heavily annotated. So let's talk about it. So like I said, VMAF has these sort of distinctions of where they fall in terms of what kind of user experience it is. And so we have 3 categories here, which is unacceptable, annoying, and acceptable. And annoying, like I said, that's anything below 80. And unacceptable, that's really quite bad. So like this is truly unacceptable, where it's like you can't really tell what's going on in the video anymore. You're not having a good time. And so again, we have a comparison here between the shaper and the self-adaptation. And starting at the acceptable bucket, we see that with shaping, 62.6% of the samples fell in the acceptable bucket, whereas with self-adaptation, 93.8% fell in that acceptable bucket. And something else that you might note about this is actually the red. So the shaper has more samples at the highest quality. So at VMAF higher than 90. And something that is interesting is that this is good for us. Like having the blue having fewer of those doesn't matter. Like having the majority of things in that bucket is more important than having a few that are above 90. So then looking at annoying, there's a really steep drop off with the shaper versus self-adaptation. So with the shaper, we still have 35.4% of samples having annoying experience, whereas with the shaper, we've gotten all the way down to 6.2%, which is approaching what you might think of as the tail of the distribution. And then finally, for unacceptable, the shaper still has 2%. And again, 2% is unacceptably high. It's unacceptable for experience, but also that percentage is unacceptable. Whereas self-adaptation, we have 0%. There aren't any samples that are falling into that unacceptable bucket. And you'll note at the bottom there, if anyone's wondering like, oh, did you just use more data and you're cheating? Like actually the shaper here is using slightly more data than self-adaptation. And so we'll probably, I anticipate we might come back to this slide, but this is kind of the way to really visualize this and see the differences in between self-adaptation and the shaper. Next slide. Okay, so what does it mean? Yes, Jana, do you have a clarifying question, or do you want to, okay, nitpicking data later. Okay, so what does it mean? I can't stress this enough. 2% of sessions is still a lot of sessions. So you might see like, oh, the shaper in that unacceptable bucket, it's only 2%, but like 2% is really important. Like if 2% of your experience was unacceptable, like that is unacceptable. And so being able to avoid that is really powerful. And the overall distributions, I think the shape of them is really important to note. The distribution of that self-adaptation is much tighter. There's the band of experience that you're getting is much smaller. And so that means like from a user experience level, you're getting a lot less ping-ponging between qualities and and that means that like we have better consistency, which we know means a better experience. The tonnage was the same. And what that means is that the self-adaptation was able to more judiciously use its data. It used it where it was mattering most to user experience. Now, another thing that people can say is that, oh, you could just shape, you could fine-tune the shaper, and that's absolutely true. Like you can spend a lot of time focusing on a given application with a given network shaper and like fine-tune it to make sure it's the very best. And in fact, operators often do this. But the problem is like applications are a moving target. Applications change faster than networks do. And also, it's very difficult to do this for every application. If there's a new application that comes online and is totally different from a previous one, all of that tuning that the shaper does gets thrown out the window. And at the end of the day, the network does not have the application level context to be able to make those decisions as well as it can. All it has is the network. Next slide. Okay, so this is going back to a CDF, but this one's much easier to explain because this is just stall duration. This is a very simple metric. Basically, if you're playing the video and you see a little spinner, that's stall duration. You count the amount of time that the spinner is up. Obviously, very frustrating. And so what we have on the y-axis here is, again, percentiles. And then on the x-axis is the duration of stalls for the session. And this chart, it basically kind of speaks for itself. But what we see is that with self-adaptation, there is some stalling, but it drops off very, very quickly. So at 1 second of stalling, we're already above the 90th percentile. So 94% of sessions have less than 1 second, 1 second of stalling or less. Whereas the shaper, we have this much more gradual shape, going really quite deep into the duration of stalls. So much so that to get to the 90th percentile is about around 5 seconds of stalling, which is it's quite a lot of stalling. Like, you know, and stalling, just like quality, is another really key important thing for user experience of video, because obviously, like, you're watching a video and it stalls, like, that's super annoying. Alan, do you have a clarifying point?
Clarifying question, Alan from Meta. What was the duration of the videos? So like 5 seconds of stalling, but what is it relative to?
This is relative to, so it's a little bit complicated, but basically, okay, Abhishek, you want to try to answer? Abhishek was involved in the trial setup, so.
Yeah, so there were 20 videos. Each one of them played for 10 seconds and then swiped away.
Yeah.
And so each video session was 200 seconds. And then there was a pause, then another video session, and so on and so forth.
Yeah, and this stall duration is per session. Any other clarifying questions about the stalls? Okay, and yeah, so anyway, and again, I want to reiterate, the tonnage or network usage here is very, very, very similar. So we're not cheating, but just by using more data. Next slide. Okay, so takeaways. I think there's kind of two axes of the takeaways here. One is that, could we actually do this? Could we build a thing that has some of the properties of SCONEPRO and do it in a real video application and in a real packet core, and use real HTTP3 playback? And the answer is unequivocally yes. We were able to do this. And it was also not particularly hard. Like, building this into the Facebook app from a application developer perspective was not very difficult. And it's also feasible to put this in a real packet core. And we expect that this should be feasible to do in other similar network deployments, especially since, as Marcus talked about, deploying shapers is also not easy. Like, so that is also really challenging. And so this is not any more challenging than that kind of thing. And then from the data, we see that the other axis here is that there are tangible benefits to end user experience from this approach of self-adaptation versus using a network level shaper. And that we can also do both application level adaptation or transport level adaptation, or both. So this test used both, but there might be some cases where only an application level adaptation makes sense, where you don't have to do this funny thing where you set a max pacing rate. Finally, the lab results here. While these are lab results and it was a very realistic lab, this reflects our real world experience with self-adaptation. We can speak to that. I know other content providers can speak to that. And what I mean by that is that we have seen in real networks where we're able to work with operators to remove shaping in favor of self-adaptation. And we do that, we spend the time to do that because it has a very tangible effect on real world experience of end users. And that is all I have.
So I do have one more clarifying question. So, was this all conducted in the lab in like a Faraday cage, or were the radio conditions varying?
Abhishek, you want to answer that, but we can go back to there is shielding, but go ahead.
Yeah, the radio conditions were kept constant. The only difference in the two, the blue curve and the red curve, was one was going through a network-based shaping at the packet core, and the other one was going through the proxy, which was explicitly signaling the limits as indicated in Mac's block diagrams earlier.
Okay, I mean, that's good. Look, interesting data, but I would expect a drive test would be more informative.
Right, and that's kind of why I said, like,
we're going to close the queue after Wes, just so you know, but keep going and keep these quick. We're already a little bit over time, so keep them brief, but good to have questions.
Right, and that's why I said, like, while these are lab results, we also have production data that we couldn't exactly share that broadly reflects the same trends, which is that when you do this in real mobile networks, you see very similar results.
Great, thanks.
Mike Bishop, Akamai. I just want to clarify, is the use of a proxy here a necessary component, What was that?
Mike, we can't quite hear you.
Oh, well, great. All right. Alan asked if I've considered being shorter. Not really. So is the use of a proxy here just for the experiment setup and like ease of proof of concept, or is that actually a core part of doing this in any way?
It is for the ease of experimentation because Ericsson had something like that available, and and we were able to integrate with that as well. I should reiterate that we are not solutionizing here. This is something that, while it has similar properties, we do not necessarily think is the form of the final solution. It just has similar properties, and
thank you.
So the word proxy does not need to show up in the final thing.
Jana Iyengar, Fastly. Just a couple of points. First, you mentioned these are shapers, not policers. The prevalence of policers or shapers depends on the region in the world. Places where equipment is more expensive, policers are cheaper to purchase.
Jana, is this a clarifying question? Take a seat.
There's one. Sorry. Yes.
Because we love you, we'll give you a bonus clarifying question.
I appreciate that. I didn't know this was just clarifying questions. My fault. Did you do experiments with multiple flows instead of just one?
There are multiple flows in this.
How many?
It varied usually from like 2 to 3.
Okay, that's basically one. Thanks.
Jana has asserted that 1 is equal to 3. Let the show.
As a non-clarifying question.
Wes Herdiger, ISI, did you try and compare like different bit rates? One of the things I'd worry about, right, is that you're optimizing for, I mean, the whole technique is optimizing for the people that are willing to not pay as much. If I want like maximum bit rate, I expect the quality to drop. So I'm wondering did you compare like 1.5 and 3, for example, to see whether the quality curves, potentially got worse because the equipment and the multiple streams were actually affecting the higher quality better? Does that make sense?
So we did run experiments with higher bit rates, but we found that the results were not like, once you have higher bit rates of video, at least for this application, and this will depend on the application, you get diminishing returns pretty rapidly. So while you can move the curve more to the right, you have different trade-offs that happen. But anyway, the short answer is yes, we can run those experiments, but for this particular application, it wasn't super relevant.
All right, thanks, Matt.
Okay.
We're going to throw to Brian now. Jump in the queue, Brian. Do you want to manage slides, or shall we?
I can manage slides.
Great.
How are my levels? Do I need to eat the mic more?
No, you're good.
Okay, cool. Do I have to? Okay, I mean, I just said I can manage slides, but you have to throw it to me, right?
You
request. Do I
request
have to ask for it?
Ask.
You know what? You do it.
I knew that was coming.
Yeah. Okay. Yeah. I always say, no, I don't need to do the training. I know how this thing works. And then it changes since the last time. So hi, I'm Brian Trammell, scone enthusiast. Seriously, I'm probably going to go bake some scones after this. The first chair slide looks pretty yummy. Here to point out that we have a problem that we. Okay. Thanks, Chris. But yeah, I'll just do things this way. So we have a problem that we think we can solve by sprinkling some DPI on it. And this feels like we've probably been here before because DPI is no longer a reasonable thing that you can talk about deploying in the internet in even the teens, but certainly not in the 20s. And I think a lot of people have looked at this and said, well, this feels kind of like Plus. Haven't we been here before? Didn't we do this thing like 8 years ago? And yes, for those of you who were there, it was 8 years ago. And I think that, spoiler alert, the answer to that question is, next slide. Not really. Yeah, Mike, I felt old when I realized it too. So since it was 8 years ago, let's actually talk about what Plus was and what we learned from it. Next slide. Because as we were preparing these, I realized some of the people in the room might not actually remember this. So 8 years ago, Plus, or the path layer UDP substrate, also known as SPUD, which I forget what the original the expansion of that was. It was so long ago. Was basically an attempt to address this problem of we need to encrypt the transport in order to make it work. Right? We knew this with Quick. With the hey, we have all of this random stuff in the network that we've been doing DPI for because one, it worked, and two, we're kind of lazy. We wanted to figure out how we could figure out how to do a generalized wire image for these sort of things, right? Like for the sort of things where you have an application where the implicit cooperation that you have between things on the path and the endpoints, where that cooperation might be adversarial cooperation. We wanted to replace that with an explicit protocol for doing these things that would be sort of like this, this layer. To Jonathan Hoyland's, isn't this a layer violation? We're basically trying to push a new layer into the stack called the path layer. You can go read all of the minutes and all of the documents. There's actually a research paper about this where we built it and showed that it worked. That's what these pictures are from. But as a generalized approach to solving this problem, this BOF did not go very well. At the same meetings, this was, I think, 2016 in Berlin. So, okay, a little less than 8 years ago, because that was in the summer. We chose Quick as the future wire image for L4. I don't think we explicitly realized that what we were doing at the time, but basically we said, the future of transport is this. It's going to look like this on the wire. And the design choice that we made there in the charter was that we wanted that to be explicitly minimal, right? Like, so we're going to encrypt all the things. What we did here is we basically decided that all of these path signaling questions were going to remain unanswered. And that's why 8 years later, we're here today talking about this very particular problem. So what did we learn? Too long, didn't read, go read a couple of long documents. Basically everything in RFC 8558 fell out of this work. Half of RFC 9217. RFC 8558 is the path signaling in the internet. I forget the actual title of it, that Ted was the editor of. RFC 9217 is open questions in path-aware networking from Panergy, which I am the author of. I think the two most important things that we learned here, most important to this effort, are one that, like, building a generalized approach that would enable complete signal replacement for everything that the path can know about everything between the endpoints in the pre-encrypted world. This seems like good engineering, right? Like, we're all engineers here. We all say, oh, why would we solve the specific problem when with one little tiny tweak we can solve the general problem forever? And that turns out to be fairly bad policy, because you get ample room for scope creep into dystopia. I remember one of the things that stuck with me in the plus BOF was, why isn't this a thing that would allow a adversarial provider to require somebody to put proof of age on a packet? Which is, absolutely not the intent, but you built a generalized tool. The generalized tool can be used in ways that you don't necessarily intend. The other thing that was like a sort of a big hairy question here was, if you have an advisory side channel, so you have this thing that's some annotation on a network stream or on a packet or a set of packets, that's right next to an encrypted channel that essentially enables the endpoints to collude, that reduces trustworthiness, right? Why should I believe what you're saying about what's on the packet, or why should I believe what you're saying about the capabilities of the network if there's already a back channel that I can watch you collude over, right? Like, so that the trust model is missing here. So how do we turn this into practical guidance for this effort? So I'd say the one thing that we learned, and this is I'll quote from RFC 8558, and I will actually read the slide. Implicit signal should be avoided and should be replaced with an explicit signal only when the signal's originator intends it to be used by network elements on the path, right? So generalized approaches here turn into They expand very rapidly because of the principle that your actual API, the actual interface that you're providing, is what a competent reverse engineer can discover about your system. And on the internet, there's a lot of reverse engineers. So in complex environments, these unintended consequences scale with the additional features, which is a really good reason to be as minimal as possible in building approaches like this. The other thing is the only way to manage the trust model here is to make sure that signaling participants are completely aligned with control points, right? That like you don't have sort of something off to the side saying, hey, it would be nice if you would send at rate X, if there's no actual penalty for not doing so, right? Like, so another way to look at this is that only credible threats of network violence will be believed and acted upon, right? Like, so a system like this, where we're talking about SCONE specifically, is only going to work if the policer is that, or like the reason that we're looking at policers is because that policer is that credible threat of network violence. Advisory signaling just turns into a spiral of game theory, and nobody wants that, especially at 1:25 in the morning. So I think a question is to keep in mind as we go into the discussion is do we believe that SCONE has these habits? And if we don't, how can we make it do so?
Okay.
And that's all I have.
Thanks, Brian. We're going
Clarifying
to kick over
claims.
to the discussions. Right. Start forming the queues now.
You want to move just general discussion, right? Yeah. Yeah. So to be clear, we're open to general discussion now, not just clarifying questions. So come on, jump back, Shauna. Jonathan.
Hi.
Oh, sorry, over there. I think.
Jonathan Hoyland, Cloudflare. I'm still confused as to how, assuming that the client has not got a direct connection to your data center, surely the place that needs to add this data has to be the lowest bandwidth hop. So it's not like, oh, we can just add this information because we know it at point A. It's some random point on the path needs to be able to add this to the packet.
Okay, let me try and just answer this directly from the floor, or when somebody can come and correct me if I got this wrong. Is that in the cases we're talking about here, the lowest bandwidth place is the policer or shaper. So it's not a network link. It is a box that is deliberately limiting the bandwidth of something. Right. And it's that box that would tell you, that would communicate out the number that it believes it's limiting to, the 2.5 in the example or whatever. So it doesn't, that 2.5 represents what that box is willing to give you for policy reasons, not the limit of what network links are capable of doing. And I'm not attributing any value judgment to whether that's a good thing or not. I'm just saying that's my understanding of what's going on here. And somebody correct me if I got that wrong.
So my question is more, how can we be sure that there's only one such box in the connection? Because lots of networks have them.
So that sounds like a good question, and one that the working group may want to take up.
Exactly. And in this case, we're just saying there's at least one box that we are interested in solving this problem for. So saying that there could be 10,000 boxes is not strictly relevant, because as long as we get that one box, we would make things better.
You only make things better if that one box is both the lowest and you have an encrypted connection to it.
And I'm saying
Otherwise,
that's the case today. I'm saying that's the case today.
Okay.
Dan.
Dan Drutza. I want to clarify some of the things that have been presented here. First of all, it's not about proliferating shaping. It's actually getting rid of shaping. We cannot identify video, in particular ABR, accurately, because the flows are usually bundled, they're multiplexed, and it actually has impact on the user experience. And so using shaping, it actually is and DPI, it actually is a very blunt tool to really try to identify, ABR flows that can adapt themselves. The other thing is that it's not about shaping or restricting on an application by application basis. It's actually about identifying specifically ABR flows, irrespective of which applications are actually creating these ABR flows. And we think we really have a problem to be solved. We needed a solution like yesterday. And this thing actually is done in conjunction with both the coordination or with the consent from the user, by the fact that they actually chose a particular subscription that has certain limitations due to the budget conscious options that they made. So it's really something that we need to address. I just wanted to clarify some of the things that I saw in the chat about, shaping and not shaping, and should it be good, should it be bad. It's not about that. And also, if we could identify other types of traffic would be great, because treating background traffic, for instance, and putting it in the right scheduler would also help. But that's not the intent. The intent is actually to be able to, for the application to be signaled that they should limit their rate. It's not about generic video. It's about ABR.
Thank you. And I will ask people to be brief, given the list has scrolled off the screen.
Jana, I'll be quick. Just so Jonathan's point, a very specific point and then a more general one. I think it's a relevant question. We should consider what happens, for example, if your SCONEPRO device actually has a higher bandwidth than the bottleneck itself. So if your SCONEPRO device is saying, hey, it's 2.5 megabits per second, and the sender goes, I'm actually getting only 1 right now, but that sounds like an upgrade, so I'm going to take it. And what happens there is something worth considering. Generally, I want to note that there is some complexity which the presentations have elided here, and I think it's worth considering those things later. I'm not saying that that stops us from doing the work, but the network itself, there's some complexity that goes into the network in understanding how to distribute bandwidth that it has among a lot of flows when there are a lot of flows. That's just a piece to think about. There's some complexity at the endpoints as well. None of that's unsolvable, absolutely engineerable. So to your questions, I would say that, is there a problem to be solved? I think there is, but I think there's an important distinction there. We should agree on the problem to be solved, because you might end up having people thinking that there are different things that we are looking to solve here. I don't know if we understand the problem well enough. Meh on that. I'm definitely interested in doing the work.
So I'm going to agree with Jana from a slightly different angle and identify what I think one of the areas of complexity is here is that we have sort of two, just looking at the conversation so far, it seems that we have sort of two, I will call them traditions of building networks and sort of network cooperative operations. We have sort of the radio side of things, which for a very, very long time has been very used to the ability to say, this traffic has properties X, so I am going to give it treatment Y, right? Like, so the whole architecture is based around sensing and reacting. And on the other hand, we have the encrypted end-to-end, right? Like reestablishing the end-to-end principle through crypto, which we've done with Quick, which is basically saying that inspection is no longer possible, right? Like, so I think we need to be, and I've heard it in a couple of just the assumptions and a couple of the way that people frame the problem is, oh, we need to figure out what this traffic is in order to assign it to a bucket. And unfortunately for packet treatment, you kind of do need to do that. I think one of the biggest engineering problems to solve is looking at this as an impedance matching problem, right? Looking at it as there's information that the endpoints have about the traffic that they can volunteer to the network that will make it work better in this very particular case, right? Is there a problem to be solved? Yes. Do we understand that problem enough to engineer a solution? Not yet. Do we understand that the problem is probably has an engineerable solution? I believe yes. And Yes, I am interested to help do this work. Thank you.
Thanks. Good morning. This is like so bizarre. I wonder, when I had my breakfast scone this morning, did someone slip an edible into it or something? Like, this is really trippy. I can't believe we're having this conversation yet again. And I was at the center of all of the peer-to-peer rate shaping, throttling back in the day, which of course precipitated, net neutrality as we know it today. I do think it's a good objective to get rid of throttling and shaping. That's super. And anything that the IETF can do to help there, that's great. I would note that there are some other mechanisms. One is regulatory action, which appears to be imminent in the United States, that would seemingly bar any kind of shaping. You could also add capacity to your network. That's always helpful, I understand. And you can also not sell what you can't deliver. I think that's another one. But of course, if there's something else that we can do here to help, I think that's great. The key is to get rid of this sort of practice. Thanks.
David Skenazy. Wow, really eat the mic here. David Skenazy, encrypting all the things enthusiast. So I think first, to respond to Jason's point, I think that would be an ideal world to live in. Wouldn't that be nice? But I don't think it matches our reality. Maybe you need to share the edibles with the class. But more specifically here, I think this is an instance of the IETF ensuring our job security for a while longer, because this all worked quite well with TCP, because you could have the middle box terminate the TCP and then turn congestion control to flow control to get the properties it wanted. And then, quick, you can't do that. And in terms of the problem to be solved, I think we might have multiple problems, and the hard part here will be to agree on exactly which one. The problem to be solved, in my view, is that right now, like the one I'm involved with is YouTube, that has agreements with some network operators, where if the client is nice enough to reduce their streaming quality, then you can get 0 rating. Again, we can talk about whether that's a good idea or not, but that's the world we live in, and as engineers, we build solutions for these things. And so making that better by having an explicit thing that the client can opt in. For me, this is a hard requirement for this, that the client opts in as opposed to the network imposing it, seems like a much, much better solution than the world we have. So to go back to the questions, I really think there is a problem to be solved. And I think we could potentially agree on it. I think we do understand it well enough. We'll have to refine that a bit more, but like the presentation about using mask for this seems like one plausible way, but there are many other ways. And I'll say I'm definitely interested and happy to help with the work.
Ted Hardy, I wanted to go back to the very basic habits of good explicit signal design, because I think this is a point that Brian was trying to make and maybe got a little bit lost in the other part of the conversation. And that is, one, you're not trying to do something generalized. You set up a signal that tells one specific thing about the network conditions to the people who care. If you think about ECN as a signal design, it's a very good signal design because there's no incentive to fake it, and it goes in the correct direction. And a signal design like that can actually improve the situation for the network and for the application, because it tells you in advance about a situation that helps you manage the relationship you have as a client to the bearer that you're using to reach the rest of the network. I think, having gone through the spin bit exercise in Quick, this particular group is very good at examining the signals that are being sent and looking for things that might be side channel attacks or might be other issues which arise from a particular signal. And I think one of the reasons I'm interested in the work is to make sure that those eyes are on something like this. I think the mask-based proxy demonstrate that this is possible if you're rich enough to have a box in everybody's network, and if you're rich enough to have the relationships with the carriers, we're asking ourselves whether this is worth doing for an interoperable protocol as opposed to side agreements. And I think, again, because of that signaling question, it is worth doing. But I think we have to be careful not to presume we know what the architecture is. This is an engineering exercise where we know what we're trying to optimize, and we know that we're trying to make sure that the signal that we're using to optimizing is flowing in the right direction and gives only the minimal data needed to accomplish the task. That's what explicit signals are meant to do, and I think I'm willing to help. Thanks.
All right, Tommy Polly Apple. So thank you for the segue, Ted. The first thing I was going to come up and say is, in addition to the resources that Brian pointed out, I do want to point people to a IAB RFC 9419, which Ted is one of the authors on, so you should read it. It's good advice. I think it's very useful when we're looking at this. It's considerations on application network collaboration using path signals. And it has a list of principles in there. I just wanted to enumerate some of them, right? Like intentional distribution, controlling the distribution of this information, protecting and authenticating that information, minimizing that information, limiting the impact of that information, and having a minimum set of entities involved with that signaling. So whatever solution we have, let's review it against those principles. I think that will help get us to a place that will have hopefully fewer foot guns. With regards to the overall direction, I think this is a good piece of work to do. I do like the use of encrypted quick-based proxies for what we see here. There are ways we can continue to optimize it. There's stuff we're doing in mask around forwarding that I think would apply very well. I think this is an interesting opportunity to add things like L4S signaling at this bottleneck link, in addition to some of these other explicit capsules. I think it kind of gets to Jason's point that, yes, we don't want more throttling, but we can use this type of mechanism to be something like L4S, maybe even slightly richer, but do that in a way that is very generic and is not something that is just favoring one particular proprietary agreement. It's also potentially related to some work that we've taken up recently in int area around proxy discovery, if we need to have generic interoperable ways to learn about these capabilities from networks. So I think just one comment overall is, I think because of all of these other existing building blocks, these Lego pieces we've put in all of these other groups, it's possible that the new protocol engineering work needed for this is quite minimal. And it's mainly extensions or just putting pieces together and describing the bigger picture in the architecture, which I think is a positive thing. So yes, probably yes, and I'll help.
Ian Sweat, Google. Yeah, I think there are definitely problems to be solved. I mean, an example is for YouTube. Their experience has been that this works really well conceptually, but is completely unscalable to try to do it with every ISP on the face of the planet. And hence, we only have a few partners. The other comment is, I think this could be used for other things. I've made this comment before, but I would love to see this as a mechanism to potentially get rid of people viewing SNI and enabling wider deployment of encrypted SNI. Because instead of it being just visible on the wire, the SNI equivalent information could be explicitly communicated in an encrypted channel to the people that need it. So I'm a big fan of that as well. I think we understand enough of it. I mean, we're going to have to figure out things as we go. I do wonder, and this is my personal thought, whether the group is going to focus on quick or quick and TCP. As an individual, I would prefer, I mean, I would love to have a solution that works for both, but I would rather have the first deliverable be focused on quick, because that's where the value is. But I did want to ask that question. Yeah. So on that point, Ian, the charter very specifically says quick, and only quick. We may be able to recharter a group if there's enough work to do, but the charter is quick. That works for me. And yeah, I think the mask-based approach, I haven't come up with anything better. Not to say that there aren't other options, but it seems fine. But obviously we have plenty of time to evaluate that, and I'm sure we will evaluate it about 14 times. And yeah, happy to do the work. Thanks.
Martin Seemann, encryption enthusiast. And despite my enthusiasm for encryption in general, I'm not sold on encrypting these bits here. I am not sold on encrypting this information here. I'd like to point out that there's value in keeping things in the open. As Jonathan said, there could be multiple boxes that are applying bandwidth limits. So if you have a signal that passes through the network unencrypted, both of these boxes could modify the bits. So that would be of value here. There's also the privacy part of it. As soon as we encrypt things, there will be a demand for stuffing more and more things in there, which might end up having privacy properties that we don't envision when we start working on this.
Hello, I'm Tom Saffel from YouTube. Can everyone hear me okay?
Just
is it
speak
on?
louder.
Okay, is this good? Yeah. Okay, let's try this. All right. Hi, I'm Tom. I lead product for the infrastructure team at YouTube. As a couple of my Google colleagues alluded to already, we have actually built something like this. And so I wanted to share a little bit about our learnings and what's worked well. I'll start by saying what hasn't worked well, which is we built it on a proprietary protocol. And as Ian mentioned, it's hard getting operators to adopt proprietary things. And so we are extremely excited about the idea being turned into a standard. I'll also add that this is something that we've been doing since 2018, and it's a project that I've owned since then. So what we deployed was a mechanism in which an operator can communicate to us what we call a max media rate. By the way, there was 2 slides on this that Ian has uploaded in case people want to look at the slides. An operator can communicate to us a max media rate, kbps. And then what we do is we apply that on ABR logic, very similar to what was described at Meta, where we basically say this will act as a ceiling in format selection. So if the value that's passed to us is 1500 and a 1080p video is encoded at 1600, it will not qualify for automatic playback. In return, the network operator does not police our traffic at all. We've been able to run this as an A/B experiment, so a fully controlled experiment, and I can just give you a few results here. We saw that the mean start time for video playback is improved by 8%. The frequency of rebuffers by 4%. The battery usage per hour is improved by 5%. And that's because you can be much more bursty on the network, so the radio can spend more time idle. And that was actually with a very small increase in video height, so also a small improvement in performance. We saw that the retransmit rate in this case was reduced by 60%, and the client observed throughput was increased by 100%. Really, we do a lot at YouTube. We have hundreds of engineers working away trying to make video playback better, and there is almost nothing more effective than access to a faster network. Mobile operators want to achieve, as been said before, a tonnage control. They're trying to limit the amount of traffic on their network, and we are fully supportive of their right to do that, consistent with the commercial products that they sell to their users and how they disclose them. And so from our perspective, a mechanism that allows them to achieve that goal of tonnage management, whilst also allowing the full speed of the network to be realized by applications, is a win-win for everybody. So to answer the 3 questions, I do think there's absolutely a problem to be solved. We know there is. I spent the last 5 years trying to figure out how we get this great principle in place in more places. So I'm very excited about this. Do we understand it well enough? I'm not sure, but it seems like we're making enough progress. And yes, on the 3rd one, Google and YouTube are interested in working on this. Thank you.
So what I was saying, everyone can check the notes. If you said something, have a look at the notes and make sure that the scribes are doing a good job. If they're not doing a good job, give them more chocolate.
Hello, Wano Park from TikTok. I'm responsible for product management for global edge infrastructure for TikTok. And TikTok is another form of short video, just like YouTube and Meta. So I can also attest that TikTok the traffic shaping is not the most optimal solution to deliver video more efficiently, which agreeing with all the points made by the first presenter, Marcus. TikTok can also attest that traffic shaping does not always result in best optimal QoE for the users. And as pointed out by Matt, 3% of outlier of bad experience is still significant of users. We also believe that if self-regulating protocol like SCONEPRO can be standardized, we'll be very interested in using this protocol and believe that this can help us deliver video more efficiently while maintaining good user experience for the users. And finally, TikTok is very much interested in to be part of this work as well. So number 1, yes. 2, yes. And 3, we have enough engineers that will be interested in to be part of this this work. Thank you.
And since you're wearing a newcomer badge, I see, thank you very much for being here and bringing us that information.
Martin Duke, Google. Seems to me that the value proposition for clients here is like vaguely RSVP-ish, which, you know, whatever the shortcomings of that as a technical solution, like the incentives are like, I mean, I seem fairly innocuous. That said, my reflex is to kind of have the same heebie-jeebies that Jason expressed, but to me, the way I'd state it is like, the good thing I would be concerned about is the effect on best effort traffic. I think the proponents have made a quite plausible case that this will actually make things better for best effort traffic because you're reducing the incentives to do kind of clumsy things with heuristics and like just rate shaping stuff. But I would always want to watch out for setting up situations where we're making it very hard for a video app or any other kind of app to just go in the normal queue and not use this service. Are we okay up there? And and also the other thing I think the other thing I'd be sort of concerned about, and I apologize this sort of FUD, is I'm a little worried about extensibility. This particular ABR case sounds pretty good, but if we have this channel, how do we keep it from being used for other things, other sorts of metadata that could be somewhat more pernicious? So I don't have a great answer to that, but I think it's something. I think we keep it in mind, we'll probably be okay. But I would answer positively to the 3 questions here on the board. Thanks.
Lars Eggert. So on the BOF objectives, the answers are probably yes, yes, and it looks like it. That said, I'm negative on this thing, and here's why. Right, operators are in love with putting in complexity to administer scarcity of bandwidth in the network, and they have been doing this for decades. Vendors are very happily selling them the equipment to do that. You know, it tightens the relationship with the operator, and this makes it more acceptable to do this. It's not good for the network in the long run. You're gonna have to put in more bandwidth eventually. Why bother putting in equipment to administer the scarcity first? It's not helping anybody, right? Also, who remembers DSL FastPath? So I'm looking forward to getting an offer from my operator to turn on video optimization for my traffic for a small monthly fee, which would make that signal go my way. And if I don't pay, it doesn't.
Hi, this is Sanjay Mishra from Verizon. So first, I want to thank to the presenters. Marcus, I think you did a good job in sort of just giving out the basics of the traffic shaping and the video shaping. And also Matt, thanks for your presentation and sharing your results. And Brian, you know, laying out some of the previous work that, you know, you did with Plus and SPUD and some of the guidelines. So I think very helpful. On coming back here on the 3 points. So I think this is a problem, certainly looking for a solution. So I think the answer to the first question is really a yes. And do we understand enough of to engineer a solution? I think broad brush, what Matt presented, it sounds like, you know, has the basic elements. And from what I heard here also from other presenters here, that more work needs to be done as Tommy was laying out and some other folks. So clearly more work needs to be done to make sure that the solution is engineered in the best way that it can be. So the answer is we don't understand it yet, but I think there's enough basis here to continue the work. So that's yes. And then certainly happy to work with Matt and others to help out with any kind of, you know, trial and field work that's needed. Thanks.
Hey, Lucas Party. So
in respect to if there's a problem to be solved, I do understand the media throttling case. That is a very specific problem, and I do wonder if there are other problems to be solved, which might relate to the other kinds of signals that might be shared. And I don't want to focus on that here because I think there's enough of a problem to be solved that this is interesting work. But focusing on what was being done for the media use case, effectively, as some others have said, this is just information that a client or a server that is receiving or sending media can already detect and determine. So in some respect, from what I've seen today, it's just about reducing the delay in obtaining those signals indirectly from the path. So that seems like a net positive because it's not revealing any information to those endpoints that they couldn't already get. And doing that in a more structured way that's standard could improve things. And if there's a case where there is no throttling in a network, the network can just indicate that it's infinity and that there's maybe other signals that they could tell us, sort of like the stuff that Tommy was saying. But the question I've got is, to whom does it signal? In the case we have here, it's signaling to, say, a Facebook app, which might have a lower layer access to the operating system or the way that it speaks to its mobile network. So I think the success of some of this work is moderated by the ability to serve those signals up the stack to applications that would be able to use them. So for example, a lot of video streaming is driven by JavaScript in web browsers. So to what other bodies, to answer like question 2 and 3, are the people here interested, or is there a problem that we understand to engineer the solution? I think there's dependencies we might need to take on in order to deliver the value that we are discussing here beyond the scope of people who can develop native apps for mobile devices. And yeah, that's it. Cheers.
Chris Nacio, Carnegie Mellon. To answer questions 1 and 3, I think the answer is yes. But question 2, I'm not so convinced on. I think there's a big scalability problem. I think we heard a bunch of interesting statements from kind of YouTube and Facebook or whatever, and I think at that scale it works. But how does this work on something where I have a device that's connected via like a MiFi, a portable cellular Wi-Fi device? What does that signaling look like, and what's that? I mean, there's obviously a channel there. There can be multiple Wi-Fi devices going through a cellular channel. What does that mean? I don't know that we have the full scope of the problem, and I wonder if the solutions that we've heard so far work well at the scale that they've been tested at, which is a provider with a network. But when you try and generalize that and deploy it much more widely, we don't actually have the model for that. And so this is not necessarily my area, but
let me just ask you a little dig on that. I think the question is, I get the problem you were talking about there, of like that type of thing. Do you think a working group could do the engineering to figure that out, or is it a basic research problem that's beyond what the IETF should do? I guess that's sort of what we're trying to
Yeah, so my problem is I'm not sure, and we haven't talked about it at all. I didn't hear anything to that, but I think that's a massive gotcha, and there's a lot of great engineers dedicated to it, and so maybe, but I'm not convinced, I guess. Thanks.
Okay, Suhas from Cisco. Can everyone hear me?
Yes, we can.
Thank you. So I think for the 3 questions raised, the answer is S, S, and S. Just giving my perspective on this one. Being an explicit signal enthusiast wherever it's needed, I think having an explicit signal in a cooperative way would be helpful for a couple of reasons. One, as presenters showed, it removes the guesswork, and also operators putting an explicit signal makes operators to be more transparent, saying that they're doing something to your traffic, and I think that brings some accountability there, which today is it's more of guesswork. And also coming from an interactive video delivery experience, I think the similar kinds of problems we also see in the like conference calls and other things, and the problems listed here would very well apply even there as well. And given that more and more media today are being end-to-end encrypted, as one of the, if the working group takes this task forward, like we need to think about what kind of information we can put in that would help something in the middle box to kind of make such kind of policy decisions and be more explicit about it. And also being a mock media or quick enthusiast, I think there are a lot of use cases in the mock that can be applied to here as well. And some of the architecture designs that we are proposing in mock can be directly applied here. One thing I would want as a working group also to think about in future is that how do we take this work when we interact with other standard bodies, like what should be the way we should get this work done if we want to get some changes done in either packet code or something like that. Other than that, I think this is the work we need to do, and there's a clearly defined problem, and we should be working on it. Thanks.
Jeff.
Hi, my name is Jeff Smith with T-Mobile US. So I'm familiar with this challenge around pleasers and shapers, and we've had conversations with multiple content providers around kind of a self-regulating solution, kind of what's being proposed here. And based on these conversations and work we've done with some content providers, I see there's absolute interest here, but the lack of a standardized approach kind of limits the adoption, since it requires kind of a one-off or a proprietary solution that the provider may not have the resources to contribute to. So from what I see, a standardized approach would be much better, and based on experience with working with various services, would have a wider adoption over the proprietary options we have today. And so with that said, I'm interested in this work, and I think it could greatly benefit. So yes to all three.
Sorry, please go ahead.
Yeah, so Julien Mazonov from Nokia. So I think my answers would be yes, maybe. I'm interested here in the scalability issues, because it looks like we have a lot of video flows that have to go through a proxy here. And I'm wondering if the experiment have been done, have evaluated how that would be performed with a very large deployment, because this might have some serious implications on the costs. And I simply wanted to ask the authors if they had some ideas about that. Thank you.
I can just briefly answer that for the authors a little bit here, which is, I think that, you heard what Ian from YouTube said of the experience of, right now, these shapers are already very expensive, or policers. Shapers are more expensive to run than policers. They're both expensive to run the network, and people are running them anyway. I think it's the general opinion. And that having something like this would mean so you could remove those out of the flows and didn't need to run as many. It would probably reduce your costs, and you're running something that's more like a mask proxy, which is a much cheaper thing to run than either policers or shapers. I'm not saying any of this is true. I'm trying to say I think that's the answer I've heard from the proponents to your question.
Yeah, I think that this is a fair answer, but the shapers first are already there, and second might still be required for other type of traffic, which is not this one. So it's not such a clear question.
Hi, Stephen Farrell. So I guess I'm going to echo to some extent what Lars said and what Chris and Asio said. So I think the answers to the questions are yes, no, and seems like it. The reason for the no for number 2 is this: if the charter text, I think, assumes that there's a way for the client here to authenticate some random box that it never heard of before, and I don't understand how that's feasible unless you think that there's only YouTube clients and Facebook clients and so on in the world. So there seems to be an possibly insurmountable problem, in which case I think the answer to 2 has to be no.
So Stephen, would it change your thinking on this if it were not in the cryptographic sense, backed by a signature from a key that, like the PKI is perhaps not what was being thought here, but in the same sense that ICMP authenticates itself, which is to say that it proves that it's on the path by saying that, by providing bits of packets that have been flying past it, for instance, as an example.
So I don't see how that would be consistent with what I read in the charter text number 9.
Okay, well, we'll have to get back to that one.
Yeah. So it just seems to me that the charter text says that the mechanism should ensure the confidentiality, integrity, blah blah blah, and not define any new security mechanism. I don't see how that's possible from a random client to on a random network to some box that's just claims it's something. So if that's not possible, then I don't see how the answer to 2 can be yes.
Yeah, that indeed may be incorrect. That may be overstating the requirement there.
So I think that leads to me agreeing with Chris Nacio and Lars in general, I think.
Leslie Daigle, co-chair of the Media Operations Working Group. I want to the questions. I think there probably is a problem here to be solved. I don't know about 2 because it depends on which problem specifically, and 3 certainly looks like there are enough people. But I wanted to echo something that Stephen just said, which is that YouTube and Facebook are not actually all the video that traverses the internet. And there are whole industries that are running their stuff over the internet, and their video needs need to be addressed as well. So that really is my long-winded, circuitous way of getting to, could you please add the MOPS working group to your list of conflicts when you schedule next time? Thank you.
Let me apologize right now. I don't know how we did that.
Sorry, Tom from YouTube back here. When I mentioned what we did before, I didn't address kind of any of the policy concerns, and I think people made some interesting points about like, well, why not just make the network faster? From our point of view, there are some like practical realities that we have to deal with about how operators behave and how they sell their product. One thing that we do, and I think that any application provider would need to do if they were going to look at this, is only to implement it if it was consistent with our principles. So I just wanted to share a few principles that we hold very near and dear to our heart, and we wouldn't use this technology if it wasn't there. One is transparency to users. So whatever restriction is being put in place must be clearly communicated by operators to users, otherwise we wouldn't do it. The second one is user choice, which is that users should be able to buy a data plan that isn't subject to any such restriction. And the third one is equal treatment, which is that we would wish to be treated the same as any other video provider, and we would only do this if we knew we were. So I do think that the policy questions matter. I don't think they're getting coded in the technical design here, but I think application providers will have to make a choice about whether or not to use this based on the principles that they want to hold true.
All right, we drained the queue, but we're going to give Marcus a chance to answer some questions here, because I think a number of the questions that came up, he may be able to deal with. Just briefly.
Yeah, so just on Lars's point about willing to sell complex stuff to operators, I mean, sure, it's good to sell boxes, but selling radio capacity and capacity upgrades is like so much more profitable, and we would be happy to do that. The problem is that the economic reality of operators kind of precludes them from just adding the capacity in that rate to kind of remove the problem from here. So I think we do have a problem here to solve, and yeah, kind of the money we make from selling a box like this is nothing compared to the capacity upgrades. But yeah.
We've got time for Dan's comment.
Yeah, well, Dan, why don't we have a little bit of time, if you can be brief.
Yeah, thank you. I put myself back in the queue because I didn't answer the 3 questions. I jumped in too early. And second, to clarify, this is not a capacity problem for operators. It's giving users choice, giving subscribers a differentiator in terms of their options on what to purchase or to acquire. And I mentioned that, yes, we do have a problem. And so yes, and yes, we're willing to participate in any way, shape, or form to get this standardized, because it's an end-to-end problem with content providers and operators, and we really need to get it solved.
So look, I'd like to get so Stephen and various people have asked the questions that come to the form of largely, do we know how, will the working group be able to figure out an engineering solution to this, how you discover where these proxies are we're talking to, and how you authenticate to them, roughly speaking? I mean, we know we'd have an encrypted context to them, what the quick connection is set up, but before that, how do you know you set the quick connection to the right box you wanted to be talking to? So I'd like to open the mics for just a couple minutes of people who think that they can address that issue and explain not necessarily the solution we'll end up using, but argue that there are solutions that the working group can do and it's a solvable problem, or that it's not a solvable problem. Just sort of think about that little problem for a second. So let's open up on that. Thanks.
Yeah, and Tom, if you want to tell us how you've done it in your deployments, which may inform things, for instance.
I can tell you, but it's all out of band, so I don't think it's particularly relevant.
Oh, okay.
Yeah.
Yeah, Marcus Ehler. Yeah, I think discovery is going to be a super important thing to solve here. And I would like to point to some very interesting work that is being proposed in int area that Tommy mentioned as well, where discovery of proxies using PVDs is being discussed. And I think something along those lines would be a very nice way to facilitate proxy discovery here, or discovery of this mechanism. That doesn't have to be a proxy. And the good thing is that it's tied to your specific access network, this type of discovery. So I think it's definitely something that's solvable.
Ted Hardy, I think it's solvable. Our Lady of Any Cast will come and bless us if we have nothing else. But I also think it's presuming a solution set that we haven't yet established as the right solution set yet. I think the idea that you find a proxy on the network and you go through the proxy using this capsule is a great demonstration of the fact that this can work. But I actually think a scalable solution that in particular doesn't require you to have that kind of relationship to the network, it would be better. And I think it would look much more like ECN, right? Where in TCP, you've set these bits that say, hey, there is congestion here, and I'm notifying you of this congestion so that you can behave in a way that causes you not to hit the congestion in the more pessimal ways TCP can hit congestion. In the same way here, if you're saying, look, there's a shaper on this, there's an explicit shaper notification, and you can avoid hitting it the way you would normally hit it by running up against it and doing the 4K down to 480 jump, if you pay attention to the signal on the path that you're getting from it. And that's a very different signaling mechanism, but it accomplishes the same thing. So I don't want us to go in presuming this mask-based solution and asking whether there's a way to do that, because I think the bigger question is, can we send a signal along the path about the characteristics of the path to the endpoint, and we have proof points that it's possible? Thanks.
Janai Engar, I'm actually going to piggyback on that because this is close to what I was going to say. But there is, I want to distill the question down. So in addition to what Ted said, I'm not going to repeat that, but yes, we don't want to think about the mask proxy as the only solution. All you need to look for is a proof that the network element that wants to signal you can also drop your packets. That's what you're looking for. If the network element can write to your packets, that means it can drop your packets, and therefore it's worth listening to. That's really all you're looking for, and there are various ways of solving that problem. So as long as we understand the question properly, I think we can solve the problem.
Anu?
Anu from Meta. So I'm trying to explain or clarify some of the questions. That is it a random box? So it will not be a random box. So the box will be a box which has all the capability or information to provide the information to client. For example, it should have access to policy, subscriber policy, network policy. It should be able to drop the packets if required. So for example, in mobile networks, it will be a packet core user plane. So P gateway for 4G network, UPF for 5G network. So because it is all the information, and right now shaping is also taking place in the same box. So that should answer the question, is it a random box? No, it is not a random box. Coming about the discovery and authentication, right now in 3GPP, I'm just taking example of mobile network, this box is already authenticated. What happens is when we come to the network or you switch on the phone, you register yourself the network and you do the authentication, right? So in that process, you have already authenticated the client in this box. So the same mechanism can be leveraged. So, and the discovery part, as Marcus mentioned, once you share the, select the access that which base station you are going to connect to, automatically you are going to select this box also. So we don't have to do additional discovery if you're trying to leverage the same mechanism which is available in the mobile networks, just for the example.
Brian?
So I basically came up here to say what Ted said, followed by what Anoop said. So endorse both of those. Very quickly, I do want to reiterate, this does seem a lot like the scope here is we're building a new type of ECN. And I think that thinking about the dynamics of ECN and also the deployment problems we've had with ECN will be very instructive for figuring out how to do this. And that actually makes me more optimistic than I was the first time I came up about 2, right? Like this is the engineering problem gets more tractable if you look at it that way.
Mike Bishop, I feel like some people are getting caught up on the fact that the proof of concept used a proxy. Doesn't have to be a proxy. It's anything that is on path and could have dropped your packets, just like the ECN markings demonstrate. And we have examples of ways that already gets communicated in the network. ECN marking is one. ICMP sending back your packet header to demonstrate that this is the packet that I dropped because it was too large or whatever. You could just as easily send back, this is the packet that I did not drop but could have. And then if the shaper tells you, I am about to start dropping your packets if you exceed this bandwidth threshold, okay, you can act on that. You can not act on that. It's just information about what is about to happen to your connection. It's tractable.
Matt Joris, Meta. So on this point about ECN, et cetera, so I agree that there are a lot of things to learn from ECN, but I want to make something clear, which is that this is not strictly a congestion problem. So Dan mentioned this, but the thing is, like, this isn't just like ECN++. Like, what we also want to know is this is an application level signal, right? Which is not something that's strictly speaking related to just whether there's congestion right now. So like what Dan mentioned is that sometimes the network might not be congested, but there are other things that the network would desire to get out of the application behavior, like data limitation for a subscriber policy reason. And us as a content endpoint, we don't want to know all those specifics, but we do want to know information that's emergent from the network that helps us do this in a way that is better for our application than having a network do it to achieve that second order effect. So while yes, there are similarities to ECN, this isn't just a problem where like, oh, if we turned on ECN today and sent ECN instead of shaping, that would solve all these problems. It would not solve all these problems.
So Jörg, we have a short amount of time.
Okay, just quickly, Jörg, on the last discussion about discovering and how to authenticate brought up, in the answers, there was always just speak of a single proxy. So how many are there? When do you know that you're done discovering? How many things do you need to talk to? And how do you make sure that you can authenticate with all of those? This is a bunch of questions that come up the moment, because you may have more than a single access network, you may have more than a single network segment. And I sense there were quite a few assumptions that there would be exactly one thing you are talking to. I'm not sure that this is in our experience enough, but maybe I just missed something here.
So again, taking example from mobile network here. So in that context, it will be one box, which will be in the data plane, and that will be a packet core user plane function, P gateway or UPF. And if you try to understand, this box is going to connect to multiple base stations, and then base station will be serving multiple users. So for all the users connected to this box, that will be only one box in the process to be selected. And the discovery is already going to make use of 3GPP procedures. So there is no additional discovery required, and authentication is also going to make use of the existing 3GPP procedures.
Okay. So hopefully that conversation has helped a few people understand a little bit better. I still get the sense that there are people there who have some concerns, but I think it's probably worth moving on to answering the question in the whole. We're going to put together a poll, and we're going to simply ask, do you think we should be forming a working group on this topic? You will reach your own conclusions about these questions and how that informs your answer, but please just give me a second.
Yeah, and look, this is guidance of how we should move forward on this. This is not a, we haven't had a charter, we haven't reviewed a charter or any of those things. This is not a, this is not the question that'll form the working group. We will have another BOF or time or area on the list to do that. But we do want to get feedback from this room of, if you, what's our guidance going forward here? Should we go do this or shouldn't we go do this? So, okay. Should the IETF form a working group on the topic we have discussed today? Yes, no. Let's give this a little bit more time. Okay. So, look, we'll leave this open for a second longer, but obviously what we'd like to hear a little bit more about is could a few of the people who are no's, and maybe particularly if it's topics that haven't already been raised or voiced that you have some concern about, if you're willing to speak about them at the mic of why you're no on different topics, we'd love to know. If it's things that have already been brought up, I guess we'd probably still like to know, but just very briefly on that, if we get a little bit more feedback of why we have a significant number of people here who are on the no side. So thank you.
Mia Kulevin, as nobody's jumping to the queue. I was actually not voting no, but I wasn't clear about this because it's not clear to me yet if we need. I want to do the work, but if it needs to be done in a new working group or somewhere else in the IETF, that's not clear.
For sure.
Hi, Stephen Farrell. So again, I think the question to number 2 issue that was discussed already, I think it's a blocker for me if I look at the charter text that was there. Seems fairly fundamental. I think there was one other point. I think there's, in some of the discussion, maybe some of the chat, there's been some lack of distinction between user and, for example, the piece of software that the user is using. I think it would help to kind of be better at clarifying that, but I don't think that's a blocking issue, but I just think we shouldn't talk about the Facebook client as the user because the person is not the piece of software.
Yeah, Chris Anasio, 99% what Stephen just said, like the answer of your device authenticated to the network and then the application will be able to know all about that seems terrifying to me. I don't understand the security model of how this thing kind of fits together. It seems very underexplored in that regard. And I still have engineering questions, so that's the fundamental no. The multipath problem I didn't even bring up yet, and that completely blows my mind.
John from Hoyland Cloudflare. Yeah, the multipath problem seems like it's just going to make this completely impossible. Okay, if you have, let's say I'm doing multipath quick, and I'm sending things on 2 different paths. That doesn't mean the paths are independent paths, right? So the first hop, for example, might be to the same Wi-Fi box, and that might be the one that's the tightest bandwidth. Or they might diverge and then come together before they, but then how does applying the bandwidth restriction, how does applying the shaping work? Because you're going to you're going to exceed the limit by twice, by 2.
Hey, this is a really deep topic. Let's go figure out the whole multipath problem somewhere else.
Okay.
But acknowledge it's not a simple problem and we didn't address it today. Zahad. Zahad, do you have any, do you want any mic time, or are you just like, no, I'm going for lunch?
Jahid, yeah, I was thinking of going to the lunch because this went really well. I have all the answers I need. No, I think we had a very good discussion. This is a kind of like, it was a non-working group forming Bob. So yeah, I mean, we can think about it. This is about like knowing what we should do. Is there interest? I think there has been really good interest by both from like mobile operator side, content vendor side, and vendor of the network. So that's good. But we have also heard that there's some issues that we need to deal with, like the architecture issue, or what kind of security model we should use, what kind of like is there any issue with processing and all these things, operational issues kind of thing. So I think there are more work need to be done. But I think you chairs have a good idea like of the summary. So that's my thinking is like, let's discuss more on the mailing list and see like where it takes. Do you want me to specifically answer something for you?
No, I look, I think that's good. That makes sense. So we'll move forward going with some more discussion on the mailing list. We'll make sure that we dig in deeper to a bunch of the issues we were raised, particularly the security, the discovery, the multiple sort of enforcement points, some of those issues. We'll clean up some charter on that. And I didn't summarize, just for the minutes, on the poll we took, we had 51 yes, 20 no. You know, so you know, there was a significant amount of discomfort with the current stuff as it stands. That's, I think, sort of how I'd loosely summarize the situation. And we'll work on trying to get some of that nailed down and more specific on the mailing list. And we'll see you all there. So I'd like to also thank everyone for just a very cordial and pleasant BOF with good exchange of information, particularly to all the newcomers again. Thank you.
Thank you.
Yes, and thanks to our scribes for what I'm sure are excellent notes.
Be careful what you ask for.
So I think we're going to need to
I think to really highlight some of the ways we need to focus. Yeah. Good job. No.